All right, so I'm starting the recording now, and volume is on, and I'm going to share the screen. All right, so you should be seeing some slides now. All right. Okay. All right, so today I have several miscellaneous topics that we're going to talk about. I'm not going to go through all of these, but they're, I'm just going to mention them for you to read through. So these are topics all related to sysadmin that we've covered in terms of like the technical aspects of them. But today we're just going to sort of talk a little bit more about them. So there, as I said, there's no common theme except they're all related to sysadmin and management, right? So as you can see here, system management and administration, so the less technical aspects of them. So the first one that we're going to talk about is this idea of namespaces. So this is so this topic relates to account management or user account management. So as you know, this is you do have a lab for this, which is posted. I'll talk about it at the end of the session today. And basically the idea here is, you have a very simple lab that you'll go through on how to configure users, groups, etc. So it should be pretty, in Linux, of course, it should be pretty good, pretty interesting and easy, I think, very straightforward. But all of that falls within, so account management plus other things fall under the name of namespaces. Okay, so namespaces is like the technical topic that covers all of it. So namespaces, as it relates to system administration, okay, so namespaces as it relates to system administration, it talks about a set of unique keys and associated attributes, okay? And really what that means is that everything that you're managing in a network or in a system administration practice can be thought of as namespaces, right? So examples of these are, of course, the account names in use, right? But you can also have another set of namespaces for the printers, the names for your host computers, like you might have the accounting computer, payroll, personnel. You have your set of Ethernet addresses, IPs, and also you have, the list of services that you're running, the list of port numbers that you're running, open, etc. Right? So namespaces is just, a single term that relates to all of that. So it's basically the set of unique keys and associated attributes that you're responsible for managing as a system administrator, okay? As an IT person or professional. And of course, that's why this week, we're going to focus on the account management lab, which is what you will do on Wednesday. And it's, as I said, it's already posted. It's very straightforward way of, talks about how to create, basic commands for creating accounts and managing them, how to remove them, delete them, all those kinds of things. And of course, access control, which is very important. Okay, so that's what we're going to talk about today. So the term namespace can be confusing, because it can refer to either an abstract concept or concrete things, right? But basically, it's just key value pairs. So it could be usernames, that's a namespace, right? All of your users. Every multi-user operating system has a namespace. And that can be the list of identifiers for your users, for instance. So every company basically, or a typical company, will have an abstract concept of a user namespace. Okay, all of the users. As you guys know, for instance, on the Windows side, something like Active Directory, you know, you can think of it in terms of namespaces of all the computers that you manage, etc. However, the namespace used at one company is different from the one at another company. Okay, it just depends on the names, but not just the names, but the naming convention. So some people use, for John Smith, J. Smith, but in other companies they might say, Mary Smith, so they might say Smith.m, something like that. Okay. In that sense, companies have different username namespaces, right? But at the end, so they have a different set, but they will all have a namespace for users and for other devices as well. So the term namespace is just that. It's the definition of the set of key value pairs that you're responsible for in your organization, where the key value pairs can be anything that you can list out and name basically in your organization. The name doesn't just have to be like letters, but numbering schemes, etc. So every namespace has attributes for each element. You guys know that, for instance, right? So account names, and this is something you will see on the Linux side, right, in the lab on Wednesday. Account names, in Unix or in Windows, they have a UID, right? So user ID. So for instance, in Linux, the root user has the value 0, and in your CVM, for instance, seed is, I believe, 1,000, right? So those usually the 0 to 1,000 IDs are reserved for processes or programs, and then after that, you have all of your users. So one of the things to notice when you're doing your lab on Wednesday is that as you're going to create a whole bunch of usernames, look at the numbers, right? So they should be incrementing and so on after 1,000. Okay. Also, account names not just have IDs, but they have home directories. So in Linux, for instance, whenever you create a user with a user ID, you're creating actually a directory for that user. Okay. So that's an important concept to be aware of. Okay. But again, this is all will become obvious in the lab. Now, other namespaces can be like host names of a computer, right? And a host name has attributes also associated with it. Obviously, there's the IP. We've already talked about DNS. There's going to be the serial numbers, right? So if you look, in an organization, all computers will have a serial number. The information of who is associated with that computer, MAC addresses, and so on, right? So that's what namespace, again, means. It's just a set of all the unique names that you're responsible for in your organization. So namespaces, the lists and dictionaries in your environment, so that can be files in the file system, right? So you're responsible for a shared folder, and that shared folder is divided into a structure where you have, you have different certification files, and then you have files on the wiki. So we'll talk about documentation today, so having like a wiki or some kind of a repository of your knowledge, right, of how to do things, how to solve the problems of sysadmin. We'll talk a little bit about that. Of course, the account names, as we discussed. Usually you want to centralize this in some kind of a database, right? And you want to have a convention of how this is done. But, that's not always possible. You have a lot of systems that... Now, with Active Directory, that's a service that's usually done on the Windows side with a domain controller, keeping track of a centralized database of accounts. But, you can have also on your Linux side, different accounts on the computers. Also printers, right? You have, a print server and a whole bunch of printers that you're responsible for, making sure they have enough ink, paper, etc., that you can keep track of that. You have names of hosts, right? All the individual computers you have in your network, and usually, what department they're in, the Ethernet addresses, and then, the services, port numbers. So remember, what kind of services you would have in your organization that you're responsible for, email servers, DNS servers, etc. So that's what namespace is. Some namespaces are flat, which basically means there are no duplicates, right? In particular, like IDs, right? So IDs should always be unique IDs. Some namespaces can be hierarchical, duplicates within different branches of a tree. But no two files in a particular directory can have the same name. But two different files called example.txt can be in different subdirectories. That's a very common thing. And of course, with everything that you do in namespaces, including user accounts, you need policies, right? So you need to have a policy in place to govern the namespaces, right? Ideally, written policies. And so you don't want to have just everyone creates accounts that are inconsistent, like somebody, J Smith or and then someone else creates Smith J, and then someone else creates J.Smith. So it just becomes too disorganized. And remember that in the end, that can lead to more work for you, right? So when there are inconsistencies, remember that, as a sysadmin, you will have to answer a lot of calls, and deal with a lot of problems. So these policies are there just to make your life easier. So namespaces need a type of a policy, a procedure, and hopefully a centralized way of creating the accounts. Okay, some kind of a centralized way, which at least, if you have a procedure or policy, that's great. As I said, when you have Active Directory, that's very helpful. And that can be done also. Or you can just set up your own database. That's also a possibility. Usually, another alternative for creating accounts is just to have like a web type of a web application, and you create the accounts on that web application. That's the central repository, some kind of a database, basically, MySQL or something. So what are some of the policies? This is pretty simple things. What names are permitted and not permitted in your namespace. So usually a lot of it is organizational, right? So, based on departments, etc. And then, but you want to have some written policies of how you select the names, how you avoid collisions, and all of that. So here's some examples of naming policies. You follow a formula like hostname PC0418 or CMIE SI06, so a department, and then the device, username, last name, and a number. You could also have by theme, coffees for printers. So this, you might think this is silly, but actually sometimes it might be better to name your printers after like a coffee than to say the payroll printer. And the reason why you may want to avoid things like calling something the payroll printer is for security reasons, right? So obviously, if you're looking for some damage, you want to go to the payroll printer and, create accounts on there that can issue fake checks and things like that, right? So in some sense, you can have different conventions. It depends on your organization policies. Right, but these are just a few simple ways of organizing your data. Things can be functional, right? So admin, secretary, guest, DNS, Web3, right? So that's very common. Very descriptive, like location, Chicago executives, and so on, right? So different ways of organizing the information. The thing is, you want to probably be as consistent as possible, okay? Because at the end of the day, remember, the more complex you make something, the more work you're creating for yourself. And then once you've created one scheme, it can be difficult to change. All right, so we've talked about this, so we don't need to mention that again. We've talked about the policies basically. Okay. All right. And then, you know, you can read through some of the rest of these. Reuse policy, you know, how soon after deletion can the name be reused? So in the lab, actually, you will have to delete an account and then archive some of the information. So you will take a look at how Linux handles that in the lab. Basically, the namespace management. So you want to have change procedures. So that's, you need procedures for additions, changes, deletions. This should be restricted to a subgroup of just admins, right? Only admins can make these changes. So the sudoers in Linux, for instance. And then you have documentation for training, you know, step-by-step instructions. So we'll talk about documentation a little bit today. And basically it should be centralized as much as possible. And then you have to maintain it. You have to create backups. Okay. And if it's distributed, of course, like at multiple locations, it does present some additional challenges to avoid duplication, etc. But centralization ultimately can provide consistency. All right, so that's namespaces. So hopefully that makes sense. All right, so now let's take a look just specifically to Linux user account management. Okay, so user account types in Unix. So in Unix, actually, how are user accounts governed? Well, you have two files, which you can see here, the password and the shadow file. So whenever everything that relates to the namespace of user accounts in Unix is governed by the password, passwd, and the shadow files. Now, these can be located in the etc folder, which, as you know by now, is the folder where you have configuration, etc. Now, the reason why you have two files, password and shadows, is that shadow is usually where you have the hashed passwords. Right, hashed passwords. And then in passwd is where you have the information about the accounts. So why not have them in the same file? Well, what happens is sometimes you have a process somewhere running on Unix that needs information about an account. So they might need to know, you know, the folder of that user. They might need to know the ID of that user. They might need, but they don't necessarily need information about the password, right? So it's not like they need the password. They only need information about the account. So the idea is that by separating these two files, you have one file that can be less secure, and that's the one that contains information about the users, and then you have another file associated with the passwd that is more secure, and it's only accessed when you actually need the password. Does that make sense? So that's really the reason why user accounts in Unix are governed by two files, passwd and the shadow file. So that's one thing that you will see when you do your lab on Wednesday. You will see that you have these two files, basically. And you can look at both of them. All right. So Unix accounts, what are the account components in Unix? So basically, as I said, each account will have a username, right? Like seed, user1, user2, the user ID. There will be a password in the shadow file. And then there's also a home directory. Plus, there's a few other things in there, the shell that you're allowed to have, etc. Now, the files, really, the files related to users are, as I said, the password and the shadow file. And there is a third one called a group file. And that's, you know, obviously the information about groups. So if you remember, you know, you have the construct of a use, you know, like user one, user two, and these are individual entities in the namespace, but they're also associated with a group. So group one. Right? And what that means is that these users can belong to a group, and then a specific group can have a set of permissions. So, you know, that's the example of sudoers, right? So whenever you have like the seed account, seed in the seed VM, it is actually part of the sudo account or sudo group, and then basically it has the permissions of an administrator. So account management relates to adding users, removing and disabling users, and setting account password policies. All right, all of these elements you will explore in your lab on Wednesday. Okay. So here we have, as we were talking about, the password and the shadow file. So these are the files that describe all the information about Unix user accounts. So in the passwd file, as I said, you have the username, UID, you have a group ID, the home directory, the login shell, and then some additional parameters in there that aren't that important. In the etc shadow file, that's the file that contains the hash passwords of the users. You can see there's the username, right, which matches there. And then you have the encrypted password, which is usually encrypted, I think, with like SHA-256, I believe. All right, or something along those lines. Also, in that file, you have information about when was the date that that password was changed, how many days until change is allowed, and how many days until a change is required, like whenever you require people to, you know, to change their password every 6 months, for instance. Then you have an expiration warning and time, so when you start issuing a warning, and you have the expiration date itself, okay? So here we have an example of both the information about the user on the password and on the shadow file. So this is the password, and this is the shadow file, right? So you can see here you have separated by colons, right? So you can see there it's separated by colon, okay? And you've got all these elements, right? So all these elements are in there. So first you have the username, student. Then you have X. This X is usually the password, but when you put an X in there, it just means, okay, look up this password in the shadow file. So the Unix just understands that, you know, really quickly, okay, the password is in the shadow file. Then after that, you have the user ID and the group ID. So this is the first UID. So you can see it's 1,000. And then in the group ID, whenever you create a user, it also creates a group, basically. And the group is the same, you know, as the user. So it's like student and belongs to the group student. Then after that, you can have some information in there, you know, have information about like the telephone, things like that. But in particular, two important things are this one and this one. So this parameter, so you can actually just, if you want to look at your password file in your own operating system, you can just do cat etc and then passwd, right? So I recommend that you go in to that in your Unix operating system. Just take a look at it, but it'll look something like this. Identify all these elements, in particular this one, this should be obvious to you. It is your home directory. So if you remember in the file system, there's a folder called home, right? And then home will contain users, so like seed. And then inside that, you're going to have like desktop, downloads, all those folders associated with your account. But usually this is your home folder. Okay? The other element is the bash. The bash is basically, if you remember, is the little program that allows you to run commands, the interpreter, etc. So if you want to disable somebody's functionality in Unix, you can just, because everything is a file in Unix, you could go into the passwd file, put in like a £sign there, just delete it basically, and then they won't be able to run any commands. Still have an account, just won't be able to run anything. Then after that, so that's the passwd file. The next file is this one, the shadow file, and as you can see, kind of this idea. Where you have an account student, right? So you have an account student, and then you have the password, right? So notice that this is the password. It is very, it's basically the hash password, and it's encrypted. So if when you took 350, you probably remember when we did a lot of exercises related to hashing, passwords, etc. And so that's the password right there. And then these parameters, just relate to these things here, right? So how to change, everything related to dates and all that. And that's it. So that's the information as you should see it in the passwd and the shadow files related to your account. In the lab on Wednesday, you can play around with all of these. Okay. All right. The username, each username should be unique. Okay. The length, I'm not exactly sure what it is in 1804 or 1604 nowadays. So it's something you can look up, I'm sure. And then naming standards. To ensure uniqueness, though, you will have UIDs. The UIDs are unique. Okay, so you can't have duplicated UIDs. A UID is a 32-bit non-negative integer. Okay, that's good. As I've mentioned before, the root user is 0, so 0 there. And then system accounts have system accounts, not non-user accounts, system accounts like the printer account and things like that. A lot of programs have user accounts. So they have the low UIDs, okay? So less than 500. I think it's like from 0 to 1,000. And then usually whenever you create an account, it's gonna be after 1,000 nowadays. All right. Passwords. So the password, the length is unlimited. It uses, probably SHA-256, somewhere along those lines. The characters can be anything except like special characters like this, like new line character. And then as you've seen before, the password is actually stored in an encrypted format. Okay, we did something, I believe, related to passwords at the beginning of the semester, but, basically you can see them here. Excuse me. All right. Group ID, the same thing. You have, so we have group IDs are 32-bit non-negative integers. Each user has a default group ID, usually the same name as their account. And then groups are described in etc group. We already saw that. And users may belong to multiple groups. So that is something else you will do on Wednesday when you do your lab. You will create some groups and then try to provide access control rules for those specific groups. Okay. Excuse me. The format, group name, you'll see this. So you have a group name, and then you'll specify like a user list that belongs to that group. So something like this. So for instance, let's say that the group is called wheel, and then you know, there's going to be some could be some password associated with it. The ID is 10, and then these are the users. So here you have root user, Walden J, Bert, you know, our Calix. Oops, that should be Calix, and CIT support, right? So all of these can belong to a group. So that's how you do it. So you'll see examples of this in the lab as well. Geckos, this is just a General Electric Comprehensive OS data. These are old things that were created. Currently, this information is for like user information, like location, phone number, email, etc. And it's an optional field, so you don't have to worry about that. The home directory, this is an important one, of course, that you will see in the lab. Every user must have a home directory, all right, where they store their files. Access control, again, remember, access control is central to Linux. And so in theory, they should be kind of just, you know, should only have access to this folder. And it's where you store all your files. So the home directory will have the desktop. And then there's also your downloads. And this is also in Windows, is very similar nowadays. Now to disable an account, you guys will be, this is one of the tasks also in your lab assignment on Wednesday. So you'll create an account, then you're going to disable the account. So how do you do that? So to edit an account, you can place, for instance, a asterisk or an exclamation in front of the encrypted password. So that the trick is, because everything is a file in Linux, right? You know, you can just easily go in and change things. So you could go in here in the etc file, right, and just, it's basically like you're affecting the integrity of the password of the hash file, right? So by adding any character along here, now that the hash is different, and so the user will not be able to log in. Okay. All right, you can also replace, another trick would be to replace the shell with something like no login programs, you know, something like that, same idea. You go into the user account, and now here, right here, that's the bash, the login, you know, the prompt that you get when you log in. You could replace that with nothing or something else, and so the user will not be able to log in. So keep in mind, if a hacker tried to do like ransomware or something like that, they could also do something like that, right? They could try to modify your account so you can't log in. All right, and of course, if you use one of the, you know, instead of modifying the files directly, you do have some commands like user mod, right? So user modification, and then a flag. And this also, you can see that in the lab on Wednesday. You know, you'll have commands to do just that. So I think one of the problems in the lab on Wednesday is basically about, you know, creating an account, deleting and disabling the account and archiving the information and so on. Okay. Now removing a user, basically you'll disable the account. You will have to remove from local files, removing email aliases, removing cron tabs and pending jobs. Remember that cron tabs is every user has access to cron tabs. Remove the home directory and you can back it up. Remove it from password, shadow, and group. So as you can see, what this is showing us is that whenever you create an account, it's not just about the user and the password, but there's a lot of other things that are associated with that user. So just removing an account does not get rid of all of this, right? So they might still have a presence in local databases and files, in cron, in the email service. They still have a home directory, right? So you will explore some of these aspects in the lab as well. But basically, deleting the account does not automatically delete the home directory. Now, what are some key points about namespaces? So the definition and policies. So you need to consider aspects related to how you select the namespace, what is the lifetime of an account, what is the scope, and what they can do on the system, and the security implications, access control. Okay, and that's basically all it is. Okay. All right, so remember that in access control, you have a file, right? So file, and then that file is associated with an owner, right? And with a group, right? So don't forget, so that's how this ties in. So whenever you have a user, you have a folder, but then you can only create your own files. Files created by other people, you will not be able to access really, unless you belong to a super user group like the sudo group in Linux. All right, so Unix fundamentals, so user accounts and file permissions, what I just said. So every account has a unique ID, belongs to at least one group, may or may not be password protected, and may or may not have a valid login program. Okay, so those are the things that you saw previously. Now, on the other hand, every file in Unix is associated with a UID and a GID, right? And of course, as you know, has a number of the protection bits, which is what I just wrote a second ago here, right? So once again, we're back to file permissions and access control. And you can see here, for instance, the etc password, right? etc password, that's a file, right? And here you can see it is owned by root, right? Some other group there, size of it, date of last modified, and then of course the permissions for user, group, and the rest of the world. And you can see all the definitions right here. So this you should already be very familiar with, but keep in mind user and group tie in to that. All right. Unix Groups, it enables arbitrary collections of users to share resources. Okay, so we've talked about this a couple of times before. The information is stored in the etc group file, and the format is something like this. So the name of the group, the group ID, and then the list of users. Most Unix systems impose a limit of 16 or 32 group membership per user, right? So these might be limited. Of course, this changes from version to version, or distros, I should say. All right, and then, yeah, like I said, some versions deviate, and some Unix systems can also have shadow files for the groups. Okay, so that's also a possibility. Group access. So in most environments, we have a central user database, users divided into different access groups, and access to systems is granted primarily by such group membership. Okay. Privileges on a system are also granted by group membership. So the classic example of this is the pseudo group, which basically they're all root users. Now the reason why we want to have, instead of just you doing everything with the root account, and instead we want to have a pseudoers group where we have, seed, user 7, and so on, is that accountability, right? So if everyone used a root account, let's say Mary and John both used a root account, you wouldn't really know if it was Mary or John that did something. You would only know that it was the root account. By having the pseudoers group, you have Mary and John, right? So you have Mary, and you have John. And so there's no need to use the root account. And in fact, and this is probably something else that you will see in the lab, the root account in Linux, at least in the Ubuntu VMs, is usually disabled by default, right? So it's not even enabled. Root account exists, but it's not enabled, or should not be enabled as a general practice, because you lose accountability by that. Instead, you should create accounts, and if you want those accounts to be root, to have the root privilege, you just add them to the pseudoers group. And that way, if Mary needs to make a change, she can't use the root, but she can use her own account. And just, that's why we type. So hopefully you've noticed that whenever, let's say you're Mary, and then you want to do something, that's why we type sudo in front, right? So sudo, whatever, cat, some file, so file1.txt, right? So if you want to read this file that is owned by root, let's say, or some other account like that, if you just run it with you, so by default, I should say, by default, your account, like let's say John or Mary, those accounts are just regular users by default. But they do belong to the pseudoers group. If they do belong to the pseudoers group, you can just type sudo in front. At that moment, it's like you're activating the privileges of Mary and John as administrators, as root accounts. And so now they can do those tasks, okay? They activate them. And so that's why we've typed sudo several times this semester. Any questions so far, guys?
No questions.
No questions.
All right, that's groups, and so that relates to the lab. We do have a few additional, like I said, today is mostly miscellaneous. So I'm just going to go through. So this concludes users, and this of course comes with a lab, but not everything. We'll have a lab. What I'll talk about today. Yeah.
Professor, I think your microphone is not working properly.
Is it a robot again? How long has that been?
Yeah, you're sounding like a robot. You just started, like at most 5 seconds.
Yeah. Let's see. All right, and let's go back to the slides. All right, so as I was saying, so we concluded talking about usernames and passwords. So you should be seeing the slides here. And that, of course, belonged to the topic of namespaces, okay? So don't forget, if on the final exam I ask you, define what a namespace is, just remember, just like, this is from your book, from your sysadmin book. All right, so now a few other things. These topics are less, I'll spend less time on them because they're just basically things that you can read. So I've summarized a lot of the chapters in that book, the management book, into just these slides. I think it's pretty straightforward, but I'll talk a little bit about it. Another thing that's important is, having, recording everything in your organization, right? So if you're doing sysadmin work, you want to have, like a wiki or a blog or something, some kind of a system that allows you to record information. So usually, for instance, this is why it is recommended that you have a ticket system, right? So if you have a ticket system or a ticketing system, the ticket system is actually very useful because it allows you, first of all, instead of, when you get to your office, there's like 6 people waiting for you to help them with problems, right? You want to have policies where, they can't just call you, or they can't just like show up in the morning at your desk, but instead they have to submit the order through the ticketing system. So the advantage of that is that, it creates an order of some kind, right? So an order number where you define a problem. And it allows you to keep track of the problem. It allows you to keep statistics of how long it took you to solve the problem, all those things. But in particular, some ticketing systems actually provide space on the order where you can write things. You can write. Like, for instance, you have the problem section, problem, and you write a description of the problem in there. And then you have actually a solution. Solution, right? And you have that. And if you can categorize the orders, this is especially important like in a big organization where you have a lot of these things. So if you can write the solution to the problem in here, like, literally like in Linux, right? You might say, this was the problem, or you actually have a wiki, and in the wiki you post a lot of the scripts that you use to solve the problem. Then here you can just put in the URL, right? So you can say, oh, here's the URL of the script that I wrote to solve that problem. This is very useful because next time around, when you get another problem in the ticketing system, you check, you do a search, right, for the problem. So hopefully it's something that is searchable. And so you can search the problem for the specific keywords, labels, etc. And then you find all the orders that are similar to that. And then you start reading through your own orders. You might identify that it might be even the same departments, etc. And then here you have some information on how to solve it, right? And that's the advantage of that. Instead of every time you have to go to Google, and remember that Google will not have solutions that are specific to your organization. Here within the ticketing system, you actually can have solutions that are specific to your organization. So it helps you also, system administrator, IT people, IT support system administrators might move to other jobs, and so they'll take their knowledge with them. But by having this documentation, basically, you're storing some of that knowledge, right? So that's the basic idea with this. So now if we look at the slides here, why document, right? So it teaches system administrators how to do critical procedures. And that way, if people go on vacation or they move on, the information is stored. Also for self-help, right? There are some users out there that, they're very computer savvy, and so they can just look up the information for themselves. So let users solve their own problems quickly, right? So they can look up this repository and say, oh, here's the solution. So remember that at the end of the day, system administration, IT support is a very time-consuming thing, so you're dealing with the same problems most of the time, and so you want to be more effective with your time as much as possible. So documentation does help quite a bit with that. Okay, so what are the forms of documentation that you can have? As I said, you can have, nowadays with a lot of technology, there's a tool called Spiceworks that is for ticketing system, but it has that functionality. You could always just create your own web application. I mean, this is standard, very basic web stuff. Database-driven web application. A wiki, nowadays you can have your own wiki for your internal organization. And then what information will you have in there? You can have, readmes, right, and text files. In Unix, you have the man pages that you know about already. Obviously, those provide information about how to configure Linux. You can also have frequently asked questions, reference lists of vendors, contact information, also certain employees, the Cisco, Linux gurus in your organization. And then also checklist, procedural of step-by-step, of how you do various things. So the manuals, basically, instruction manuals. But as I said, a ticketing system can also be very useful. And then, basically this is just very basic stuff. What information you store. What are the sources of the information? Now, if you want to get information of how to solve something, obviously, in Linux, for instance, there's command history. So you can just type, I strongly recommend that you try this command history in Linux, commands, and then just type history. It'll give you a list of everything that you've typed, so you can always take that. Scripts are also very useful for this. You write a script and it's repetitive, but it's also the knowledge is there on the script, right? So next time around when you need to do the same task, you just use the same script. So that's screenshots, obviously, grabbing the steps that you did. Sometimes a lot of it is recorded via email because you're exchanging information, right, with people. And then, as I said, the tickets, right? So the ticketing system, the problems, solutions basically are often documented in the notes. This is actually very, very useful in particular, I think. And the better you organize, if you're very organized, like you always, if you get something and you say, oh, this is a Linux, this is a Cisco, you organize your things, it'll help you to find the answers later on. Okay. As far as where you store it, obviously some shared directory. I showed you the other day how to create your own web server to feed files. So a website, obviously, you can create an actual web application or a content management system of some kind, like a wiki or something like that. All right, so that these change based on technology, so you guys know a lot about that. Wiki, I've already talked about it, so there's no real reason to talk about that. Version control, also that can be useful, like GitHub, right? Whenever you, especially if you have a practice where you have a lot of code, GitHub allows you to do version control. And you can revert to older versions when you make updates. So certainly a version control system can also be very useful. Searching, of course, is going to be important here. You have various, like I just described, if you develop a web application, you want it to be searchable. Obviously, if you have a whole bunch of files, you also have grep. You guys have learned about grep and awk. And, there's various other things. There's even like, index, crawling and all that. But you even know your Windows operating. So actually, Windows has this feature that I almost constantly disable, which is that indexing feature where it indexes everything, so it makes searches easier. But I just dislike the CPU consumption that it has. But anyway, so that's the idea, right? So if you have a lot of data scattered all over your organization, you could even write like a crawler to collect the data and have it available. At the end of the day, it's all about having information that's accessible really quickly. Right? Yeah, and then, this is just additional things. So what else? We've talked about all of this. Repositories outside the organization. Obviously, you can check Linux pages on the internet. And then you know about the man pages, so you know about that. And that's it. Yeah, so that's pretty much it. I think that's enough to kind of discuss documentation, right? So the idea is that, from the managerial point of view, as it's a knowledge-based service, right? You're providing a service very much based on knowledge of technology and problems and solutions. So keeping track of all of that in an efficient way is an important thing. Okay, and that's what these slides were about. All right, so are there any questions about this section on documentation?
I don't think so.
Yeah,
Sounds clear.
that's pretty easy, right? All right, so as I said, these are just a whole bunch of chapters from your book that I've summarized in these slides. And that's I'm just going over the main ideas of it. All right, so that concludes namespaces and documentation. All right, and now we're ready to move on to the next topic. So let me close this. So as you know, as I said, today we're just doing a lot of miscellaneous things. So all right, so this slides I'm done with. Okay. All right, so let's look at the next one. Yeah, let's look at this one. Customer care. Yeah, so that's a good. Let me share the screen. All right, so this is customer care. All right. So you should be seeing now the slideshow. Customer care again. So sysadmin, system administration, SA, is a very service-oriented practice, right? That means that for the most part, some person has asked you, whether it's your boss, a colleague, or it might be or it might be an actual user of the organization. They might ask you to help them with something, right? So that basically means that, it's not just something like where you're coding and you're in your coding group and you're just writing code, but you don't really interface with users. Here you might actually need to interface with users quite a bit. So that falls under this idea of customer care, okay? Customer care. And so, so this gets them to the idea of, being a good salesperson, right? Salespeople, being a good salesperson, you're providing some kind of a service. So as it turns out, research has shown that salespeople, whether or not they realize it, they actually follow a specific structured method involving specific phases or steps, right? So we always think, oh yeah, salespeople, they're such, they're charmers, right? They try to be charming with us and they try to be friendly and, how are you doing? And they try to get your attention and make you feel comfortable and almost feel like they're your friend so that they can then sell you something. So they're trying to build that relationship, right? And that's the same here with what you're doing. The idea is that, they're for customer care, regardless of what it is, but, particularly for the IT practice, right? You don't want to be like, I always make this joke, which is a little dated at this time, but I don't know if you guys remember in Saturday Night Live, there used to be this guy, Jimmy Fallon, right? So he would do this role of the IT guy or something, and it was really funny. He had like 18 beepers on his belt, and so, but he was just very rude. He was very rude, because that's sometimes the like the classic persona of the IT person in the organization. They treat the other users like they're not very smart, and they're just like, So I strongly recommend, if you've never seen Jimmy Fallon, just Google like SNL IT Jimmy Fallon. You'll see I think it was called the IT guy or something like that. But anyway, you don't want to be like that. You don't want to be like that. All right. Instead, the idea is that you should consider that your job is, although you're a very technical person and you know a lot about IT, Nick Burns. Oh, okay. Yeah, so the character was called Nick Burns, someone said. Yeah, so check him out. It's really funny. But you don't want to be like that, right? You don't want to be rude. You don't want to be like snarky and that you know everything, that people don't know anything, but the opposite. You need to be provide really good customer care. So as it turns out, it says here that salespeople have a specific structured method and phases or steps for performing this service. So low performance had little or no consistency in their method. So what this is saying, I'm not going to go into too much of it, but basically that there's a procedure that you should develop to provide services. So system administrators spend much of their time responding to requests from customers, okay? Responding to customer requests in a more specific task than the general issues that surround running a help desk. All right. So customer requests are the trouble tickets, calls, problem reports, or anything, right? So just a user showing up, etc. So therefore, how well you respond to customer requests is critical to maintaining an organization's reputation, right? So some thought needs to be given, not just to the technical know-how, but the way that you interact with users. Okay, so here basically this is really like the meat of these set of slides. So here this provides a basic method that you can follow for interacting with your customers. So the method for processing these customer requests has, sort of 9 steps, which can be grouped into 4 phases, right? So phase A, phase B, phase C, and phase D. And really it's about, the hello, then the what's wrong, then fix it, and then verify it. All right. So this is, it sort of has been determined that this is a good, successful way of interacting with your customers, right? So, the greeting, just be friendly. You don't have to spend too much time on this. That's not what this is saying, but just, be courteous, right? And then, start the conversation. Then you start to identify what the problem is. So what's wrong? So you want to classify the problem. You want to figure out what type of a problem it is, figure out the problem specifically, and then make sure that you understood the problem correctly. Then once you know what the problem is, that you're clear with everything, you can do the execution, so fix it, right? So you fix it. So you come up with some ideas on how to fix it. You select one of them, and then you execute it. Okay, and then the final phase is the verify it. So you verify that you did things correctly. So, and that means in particular that you verify with the customer, right? Because you may have misunderstood something. Maybe it works because you still know a lot more about computers than your users. So you really want to make sure that your user feels that the problem has been fixed and is closed. And that's it. As you can see, and this is just a suggestion of an approach that you can take for dealing with users. So the idea with this is that it gives, this method gives you structure, especially if you're, like a new system, sysadmin, etc. So it helps you to solve more efficiently the problem, plus it helps you to have a good relationship with your users. Okay? All right, here you can see just a diagram of the same thing. So see how this summarizes it in one slide. Okay, and then, the rest is pretty much, it just elaborates on all the steps. So that part you can read on your own. We don't have to, because it's pretty self-explanatory. Okay. So you can take a read through all of these. All right. And then, yeah, so you can see here. All right. So the next topic that we're going to talk about is the help desk. So again, today we're just a few miscellaneous topics. So as you know, the help desk is, we're going to provide a formal definition of it, but as you deal with sysadmin, right, whether you're configuring operating systems in Linux or in Windows, yeah, you want to have, you want to have some kind of a central presence for providing these services. So that's usually called a help desk. So a help desk is, it's a place, but it doesn't have to be a physical place. It can be real or virtual, right? Where people can get answers to their computing questions. They can report problems or they can request new services, right? So usually we do this via email. A lot of the time we just need to know a contact person, or you call via the phone, or sometimes you even have like a little window and you go there and you ask for a service or help with something. So the help desk is obviously really important in an organization because, as you know, computers will always have problems. And for the system administration group, the help desk is actually the face of your organization. Okay, so it's important to have one and to manage it well. So the basics of it, simply to, if you're a sysadmin group or the IT department, you're the IT department or the sysadmin department, whatever you want to call it, the basics of it is you want to have a help desk. That's the first thing. You want to have one, and you want to ensure that it has, it's friendly, accessible to people. You want to have enough staff to support the traffic. You want to definitely define the scope of coverage. And, so that just basically means you want to define policies of how people request services, etc. Okay. So we've already talked about this, so I'm not going to repeat it, being friendly and everything. Corporate culture. So these are things that are, self-explanatory. Have enough staff. So that's obviously that makes sense, having enough people to handle the problems. Now let's focus on this one a little bit. So define the scope of support. So this is important actually. So a help desk should have a policy defining the scope of support. What that means is you're not there to solve every single technical problem in the world, right? So you should define what problems you can help with and what you can't, right? That's not within your scope. So that's why you need to define that. So this document explains what an SA group is and isn't responsible for. So it's the components of the scope are what, who, where, when, and how long, right? So you're not there to answer questions at 3 a.m., right? Those kinds of things. So that it sounds trivial, but it's good to have something like this. So what is being supported? Only the PCs, the LAN itself, the networking. Do you only support Windows, Linux, Mac? Do you support phones? What exact, or smartphones, I should say. What is it that you're there to support? Is it only specific versions, specific operating systems, right? Which applications are being supported? And then what happens also if you have unsupported platforms? What are the policies there? Is it basically that they shouldn't even be in the network anymore? Those kinds of things, right? Because they might be insecure. A lot of the time falls related to security issues, or it'll be related to the amount of work that your staff can actually handle. Okay, guys. All right. Is there no support if in the off hours? And then also other things like how long an average request should take, and the ticketing system is helpful for this. And so a lot of this, in summary, a lot of this is just the policies related to what you're responsible for. Okay. Okay, dealing with things that are out of scope. So how do you, how do you deal with that? Specify how you actually provide help. So for instance, like I said at the beginning, this document would tell customers what to do to get help, by phone, email, a ticket system. So usually you want to avoid, customers that just show up at your desk because you're probably busy with something else, right? And so they take away time. Also, you don't want to spend all day just answering emails. So there's got to be some structure to how you do things. Right? You want to define some processes for the organization, so of how to do everything. Even how to escalate. So establish an escalation process. An escalation process is just, when should you move it up to your manager, etc. Or to, maybe you have you have this for instance, there's a statistic out there that says basically that 80% to 90% of calls are, very repetitive, very simple things, and then there will be that 20% which require escalation to experts, the Linux guru or the networking guru, etc. Usually those people in a second tier, they have more experience, more training with, specific issues like that. Define what an emergency is in writing because, and this is very true, right? So everything is an emergency. I mean, regardless of who it is, right? So for that specific person, when they can't get something done, we're all like this, right? So I know if I want to print something and the printer's not working, I get really frustrated because I just want to be done with that and move on to something else. So for me, that could be an emergency, but obviously for the organization, that's not an emergency. So you want to have that written really clearly in your policies, what exactly is an emergency, because, so that you can prioritize it, right? So if it's just me coming in and saying, well, my printer doesn't work, well, that's probably not an emergency. So it'll, they'll solve it when they can. So that's the idea. So you want, in the policies that you have in your system administration practice, you want to define what is an emergency. Okay, this is, all right, so let's see. Out of hours and 24/7 coverage, so that, that just depends on the size of the organization. Communicating is really important, actually. So making sure that the policies are made available, maybe have them online, that can be very useful. Communicating to people what these policies, and I would say in particular, that people kind of accept. So they need to be reasonable things. You can't also say we will only deal with problems from 8 a.m. to 9 a.m., right? So it's got to be something that's reasonable for everyone, for your group, and also for the organization itself. Okay. All right, and I would say the last thing, I thought I had a slide on this, but I guess I don't. The last, it's probably in here somewhere. The last thing, of course, is that, you need to have the support of management, the CTO or whatever, Chief Technology Officer of the organization is usually the person that needs to kind of, support your policies, because ultimately they're the ones that you're going to pass it on to them. And so that's an important thing. All right, any questions about this section, guys? So on help desks, any questions?
No questions.
All right. So I think, let's see, we've talked about several miscellaneous topics today. Let's see, what else do we have? Automation. Oh, I like this topic. Automation and coding for sysadmin. So this is a nice one, right? So as you guys know, one of the common themes in the course this semester has been automation. Why? Because again, it's all, if you're inefficient in this, it can, might end up being not very productive. Also, you might end up repeating a lot of work, right? You're repeating a lot of work. So that's why, solving things with scripts, documenting, etc., is very useful because it allows you to have a lot of automation. So this probably should say scripting instead of coding. But scripting. Right, so automation is an important topic, and again, from the managerial point of view, it just makes you more efficient. The information is better documented, etc. So you're using the right tools for the job, so the things that we have available in Linux, obviously shell, bash, right? So bash is one of the programs that we have available. It's available and reliable in most platforms. And basically it allows you, it's a scripting language that allows you to run scripts very much like Python. Okay, very much like Python, you can run your scripts and automate pretty much all functionality in Unix. Other tools that we've looked at, Python in particular, we looked a little bit at Perl, not so much. And then there's, Ruby on Rails. There's other scripting languages out there, right? But we looked at Python as a scripting language. So these are suitable for moderately complex tasks. You can, you can use Bash, of course, and some of you I know really like Bash, and that's great. I use Python, but that's entirely up to you. You can write pretty much a lot of the same scripts from Python in Bash. As you know, everything is a file in Linux, and so because these scripts allow you to manipulate text, they're very they help you to automate a lot of processes. And there's a wealth of libraries available for these scripting languages. So and that's one of the things that I've demonstrated throughout the semester is that we can automate a lot of things by using these libraries and using Python. You saw one of the last things we did was like geolocate, and you saw we used some libraries for that. Other languages out there that you can use, JavaScript and PHP in particular, if you want to develop like web applications for your servers. So these are other languages that certainly you can use. C, C++, this is something that you use a lot less of for sysadmin specifically, but it can be useful for some things as well. Okay, you might create your own applications, right? In C, and in particular, if you need performance, etc., C is definitely one of the fastest languages out there. You can read that joke later. So anyway, scripting languages. What are some of the advantages? There's a short development life cycle, right? So hopefully you've seen that one of the things, in particular with Python, is that it's really easy to use. A lot easier to learn than, say, C or anything else like that. They're very good at string manipulation. They can easily handle multiple files and inputs and outputs. And in particular, there are tens of thousands of general purpose modules or libraries available. So that they give you a lot of power. Okay. Some disadvantages. Well, they're not, you have to write a little bit of a script, so they're not like a tool that's specific for something. There can be some duplication in the scripts, I guess. Yeah, they're not focused on security. We're just trying to do something, perform a task. And everyone will have their own favorite languages, So some people will like Bash, some people will like Perl, some people will like Python. So everyone has their preferences. But in essence, for me, I think scripting is very useful. Obviously, on the Windows side, there's also PowerShell. right? So, you know, so it's certainly something that it's important in sysadmin. And you just have a lot of tools. So I've shown you with, you know, how to do a lot of things with one language, Python. Once you finish this class, couple of weeks, now you're free to select the language of your choice and, you know, just continue learning on your own. But at least now you have a sense of what you can do with scripting languages. And that's it. All right. So, all right, this is a good stopping point. So today, I know it's a long lecture, but let's kind of stop here. All right. So in summary, basically today I just wanted to go over some of the managerial aspects related to system administration. Okay. These are topics from your book. Okay, and I just wanted to mention them. I strongly recommend that you read through this, give some issues. So certainly take a read through those, and some of those might be questions on the final exam. Also, I remind you on Wednesday you will be working on a lab. So the lab is the user account management lab. So I'll talk about that lab on Wednesday. Otherwise, I'm going to stop the recording now.